Okay, so next we're going to go over this question, which is also from the exercise sheet. Now, let's first go over what the question is. So it's asking us to prove that this language over here is not regular. And this is a language of strings over alphabet A, B, where the first section of the string is the reverse of the second section, or vice versa. So the second section is the reverse of the first. So for example, we could have A, B, B, A, because the second section is the first in reverse, right? Now, one thing to notice is that this language only has even length strings. Why? Because let's say the first half has k characters, okay? Then the second half also has to have k characters because the second half is just the reverse of the first. And so the total length of this string will always be 2k some k. And this is always an even number because it's 2 times by something. So the length of this always even. So that's one thing to note. So it's asking us to prove that this is in fact not regular. And so we're going to use the pumping lemma for this question. Oh wait, one thing I want to note is that, for example, this here would be in the language, but then, for example, this wouldn't, because this has odd length. Okay, so we're trying to prove it's not regular. Therefore, we're going to use the pumping lemma and prove it by contradiction. Okay, so I've written out all the boilerplate for this question, and so all that's left is to move on to the main part of the proof. So we're looking for a string that's in the language with length at least n, where there does not exist a breakdown, where the three properties hold. And one thing you should always think about when selecting strings for the pumping lemma is this property over here. So xy has length at most n. So what this means is that if you set the first n characters of the string to be one single character, then x and y can only contain that character. So for instance, if we set the first n characters to be a, then we've essentially restricted the amount of characters x and y can contain to just be a. So if we do this, x and y cannot contain b's, it can only contain a's. And that reduces the amount of cases to consider. Because remember, you have to show that all breakdowns lead to an issue. And so if we make it so that no matter how you break it down, x, y can only contain one type of character, we've reduced the amount of breakdowns we have to consider. So for instance, if we instead had ban, then xy could actually have a b somewhere inside of it potentially, because the first n characters consist of a's and b's. And so if you were to try to prove that a string like this were not part of the language after pumping it, then you'd have to consider the two breakdowns you could have. So one breakdown is where xy consists of both b's and a's, and the other breakdown is where xy consists of only a's. So you'd have more cases to consider. If we instead only have the first characters be a's, then there's only one breakdown to consider, and that's where x and y have a's inside of it, nothing else. And so let's move on to selecting a string. Let's think about a bad string first. If you were to have a to the n, a to the n, this would be in the language because this is the reverse of this, and the length of this would be at least n because the length is 2n. But why is this a bad string? Well, because if you just think about it, then there is in fact a way of breaking this down. Any breakdown where y has an even amount of a's will lead to the third pumping limit property to always hold. So there is a way of pumping it and breaking it down, where by pumping it you get strings that are still in the language. So we let x be epsilon, let y be even amount of a's, which mathematically is just a to the 2k for some k greater than equal to 1, and z will be the part of the string without y. So it will be this. And this might be confusing, but it's essentially just saying that we're breaking down in a way where y has an even amount of a's. That's all this is saying. And so if we pump down, what happens is that we remove some even amount of a's from the string. And so that would still be in the correct form, right? Because we will still have just a bunch of a's followed by a bunch of a's. And that's still in the language because there's still an even amount. By pumping up, we would just be adding even more even amounts of a's to the string. And by adding that, we would not take the string out of the language because the amount of characters is still even. And because the entire string is just a bazillion a's, it would still be its own reverse if you split it in half. And so we have found a breakdown for this string where the properties hold. And so we can't reach a contradiction using this string, so it would be a bad one to choose. Instead, we want to think of a string where adding or removing characters from the start would be problematic. For instance, let's think about this one. Uh, Something like this. So if you split it in half, it's a sort of reverse. And let's just think about what happens if we add characters to the start. So if we were to pump A up, then we'd be adding more A's to the start. And so it could not possibly be in the string, in the language, right? Because the second half wouldn't be like the first half. We would have gone from something like this to having even more A's at the start. And if we're adding more A's to the start, we're kind of like pushing these B's into the other half of the string. And so the first half of the string wouldn't have any B's, but the second would. And if the second half has B's and the first one doesn't, then the second half could not possibly be the reverse of the first. So let's try write that down in words. So this is part of the language, and its length is going to be 2n plus 4, which is greater than or equal to n. Therefore, there must exist a breakdown such that the three properties hold. Now, as mentioned before, by property 2, no matter how you break down the string, x and y will only contain a's, because the first n characters of the string are a's. So, by property 2, xy contains only a's. Then, by property 1, y is not empty, so it also has to have at least one a. So, by property 1, y contains at least one a. Okay, so now we know that y has at least one a. And so if we were to pump y either up or down, my claim is that the resulting string would not be in the language. So let's think about what happens if we pump up, as mentioned before. By pumping up, we add more A's to the start of the string. So if we let k be the number of A's in Y, then for example xy squared z would equal, so it will be this string with k more A's at the start than before. So it will be a n plus k because we've added k A's to the start since y contains that many A's. And if you look at the string, then it's obviously no longer symmetrical, right? Because if you split it in half, the halfway point is no longer going to be here, since there's more letters over here. So the halfway point will sort of be shifted to the left, and so it will no longer be symmetrical. And if you pump up enough, so if you do, for example, 10 instead of 2, you can also say that the first half of the string will no longer contain any B's while the second would, and so they can't be symmetrical. They can't be the reverse of each other, so they can't be the string. So by pumping up, we add more A's. I already said it before. So by pumping up, the string, the resulting string, is no longer symmetrical. Therefore, xy squared z is not in the language, which contradicts this property over here. Therefore, L by contradiction, L is not regular. So just to reiterate, if we had this string over here, and we add more A's to the start, so it's like A. So before, the midpoint was over here. If we add more characters to the start, then the midpoint shifts to the left, right? So it'll shift to the left. And so the first half of the string will no longer match the second half, and so it's not in the language. I could have worded it better in the proof, but I hope you sort of like get that main idea. Okay, so that's that question. Moving on to the next. If something wasn't clear, just let me know. I'll explain it again.